way you look at it.
Oh, that means we've got to see him in person, doesn't it?
So there's only one online exam, which means you will get electrical questions and you will get mechanical questions in the same exam.
Mm-hmm.
Oh, yeah, that's easy.
Yeah?
Yeah.
So this week I've prepared the electrical questions, and next week I'll try and twist Pat's arm so he can do the mechanical questions, because I'm sure he can come up with better answers than I can. So let's have a look at some of the potential electrical questions that you might get subjected to. So if I click on this, hopefully, he says, it is going to work for me. Right, first question then. Can you all see that all right?
Yeah.
Yeah.
A data sheet for specific components that you are using in a design for a printed circuit board refers to conductivity. Which statement best describes electrical conductivity? Anybody want to take a crack at that before I show you the options?
I reckon Owen will have a better idea at this than me.
Wait, what?
What do you reckon, Owen? Do you want me to give you some options?
It's in it something to do with the amount of current that a certain material can carry.
Here's our four options.
I'll
The
put that
degree
as a
to which a specific material conducts electricity, the measure of how strongly a material opposes the current flow of electricity, an electromotive force or potential difference, or a flow of an electric charge.
A.
Yeah, A, I'll go with A, yeah. A, yeah.
The clue is in the question, isn't it? If you look at the question, think about it, we're referring to conductivity. So let's look for the one answer that says conduct in it. What is the measure of how strongly a material opposes the flow of current then?
Say again.
Well, let's look at the other answers just out of interest. What is a measure of how strongly a material opposes the flow of electric current? What do we call that?
Resistance.
Absolutely. The Borg might say it's futile. So the objection to current flow is called resistance. So conductivity is how much a material actually allows electricity to conduct. All right with that one?
Yeah.
Number two then, you're required to check current flowing in a section of an electrical control panel. Which measuring equipment would you use to measure current? And here's your options. Would you use an oscilloscope, an insulation tester, a multimeter, or a logic probe?
Is it a multimeter?
It certainly is. Now, me personally, if I was
I thought a multimeter didn't test current. I thought you had to have the clamps for that, the 325 clamps.
Personally, if I was checking the amount of electrical current flowing in a section, I would probably prefer to use a clamp meter. Because to use a multimeter, you'd have to break the circuit open and put it in series with the circuit, wouldn't you? So that's not the best of questions, but this is taken from their question bank.
I was going to say, I didn't even know a multimeter gave you the option.
Think about a multimeter. What options are on a multimeter?
I thought pretty much everything other than current. I don't think I've ever used it to test current ever.
Yeah, but what else can we do on a multimeter?
Voltage.
Yeah.
Resistance.
Yeah.
And all that jazz.
Voltage, resistance, and all that jazz. Let's have a look. Just have a little look at a multimeter then, just for a second. So take that off. There you go. Can you see that all right?
Can't see out.
Yeah, yeah. I can
I
see
can see
that
it.
fine.
Yeah, I can.
Just me then.
Right. So here's a multimeter.
I
can
can see it
me-
now.
We can measure voltage. We can measure resistance. This one's quite advanced. It measures
That-
capacitors and frequency, but it also measures current. Now, when we measure voltage, we put it in parallel with the circuit, so we put it across the circuit. When we measure resistance, we put it in series with the circuit. So, if we've got a supply, we would measure the voltage across the circuit, and we would measure the resistance in series with the circuit. Okay?
Yeah,
It's coming back now. Is the fog clearing?
a little bit.
A little bit. Okay, so the correct answer there would be a multimeter. As you mentioned, and as I said before, personally, if I was inspecting in a panel, I wouldn't expect to be open circuiting connections. I would want to use a clamp meter, which would simply clamp round the wires and then give you a current reading without breaking into the circuit. Next question then. Can you see the questions okay?
Yeah.
Got them back up. Portable electrical generation equipment has the potential to cause serious injury. It's covered by the Electricity at Work Regulations 1989. The regulations state that the equipment, is it A, undergoes a mandatory test every 6 months, B, is maintained in a safe condition, C, replaced every 2 years, or D, is never used by anybody under the age of 25.
D.
D.
A. Would it be A?
What do we think then? The Electricity at Work Regulations.
A, because pat tests are legally required, are they?
Different equipment, though, has different
Yeah.
periods of time between pat tests. So every 6 months would be a bit of a random number, wouldn't it?
See, right, this is why I hate questions like this, because if it has a pat test every 6 months and you're basically maintaining it in a safe condition anyway, so why does B even exist? The point of the pat test is to make sure it's in a safe condition.
Yes, the point of a pat test is to make sure it's been maintained in a safe condition, isn't it?
So what's the point of having B on there as well? It's basically just A, just not as in-depth.
Tell them again.
What do you think, Josh?
I'm the same as Megit, to be fair. I think that it's a bit mumbo jumbo. As it's everything that you use has got to be in a safe condition, otherwise you can't use it. So I feel like that's the obvious one to go for if you're gonna go for one. Is just that it's got to be maintained in a safe condition, otherwise you shouldn't be using it anyway.
Yeah, exactly. Remember, the Electricity at Work Regulations was written in 1989 and came into force on April Fool's Day 1990. And it hasn't really been updated since 1990. So 30 years on, technology and everything has moved on a lot, but the regulations haven't. Now, pat testing, although was ongoing 30 years ago, wasn't as extensive as it is now, and it's changed and it's evolved. But pat testing is only used as a method of maintaining that or establishing that equipment has been maintained in a safe condition. Now, some of these questions, the way they're written, if you look at those 4 answers, you could completely dismiss C and D straight away. Replaced every 2 years. How do you know it's going to wear out in 2 years? How do you know it's not going to wear out in a year? It might last 10 years. And never used by anybody under the age of 25. So you're down
Just
to A
see.
and B anyway when you get a question like this. But if you think about it, all PAT testing is doing is establishing whether or not it has been maintained in a safe condition. So you carry out the PAT testing to achieve the requirements of the regulation that it's been maintained in a safe condition. So the answer would be B. Do you want to come back on that one, Maggie?
No, I'm all right.
You're happy with that?
Yeah.
So which answer would you have gone for when you took the test?
I'm pretty sure I did go B when I did it. But
Excellent.
it was just when I read it, I was
Yeah.
A and B not far off the same anyway.
If it had just said undergoes mandatory portable appliance testing, that might have been a different case. That might have thrown you off. But the fact that it says every 6 months, some equipment can go 6 months, some equipment can go 2 years, for instance.
Yeah.
Other equipment has to be done. For instance, a hire company, if you hire an electric drill from a hire company, they have to PAT test that drill every time you hire it, every time it goes out on hire. So as soon as it starts putting specifics on dates and stuff, then it's probably the wrong answer, unless it's referring to a particular regulation. Next one then. You've traced a fault back to a circuit breaker that is stripped out. What is the purpose of a circuit breaker? What does a circuit breaker do?
Protects the circuit or the user, doesn't it?
In what?
Circuit breaker just protects the circuit, doesn't it? It breaks it when there's a fault on it.
Yeah.
Like, stops it from frying everything and blowing up.
Stops it from frying. And what was you saying, Josh? Protects the...
I said it protects the circuit, but I thought it would have protected the user as well. But
Let's have a look at the options. Protection against direct physical contact. Does a circuit breaker stop you from touching it?
No.
No. Does a circuit breaker protect against overcurrent protection?
Yes.
yeah,
Does it protect against overvoltage protection?
That's RCD, isn't it?
No, you get a separate overvoltage protection device called a surge protection device.
Oh, right, yeah.
And excess frequency protection?
No.
No. The whole idea of a circuit breaker is to make sure that a maximum amount of current flows in a circuit. When we design our circuits so that they will actually trip the MCB. We call it the ZS. We actually calculate the size of our wires and everything based on the amount of current that's going to flow in a circuit. So the MCB is just there to stop there being too much current. For instance, if a motor seizes up or a coupling seizes up or a gearbox, when a motor starts trying to turn and it can't turn, it will drag more and more current. As more and more current flows, it will cause the wires, it will cause the motor to then start heating up and could cause physical damage. By having overcurrent protection by the means of a circuit breaker, it will trip the motor out and then you'll have to go out and investigate. All right with that one?
So the RCD is for leakage, isn't it?
Yes.
It's
An RCD is used. The MCB, the circuit breaker, is there to protect against overcurrent. We use an RCD to protect against fault current going somewhere it shouldn't. So go back to our motor. It's overheated to the point that the insulation has now started melting off the wires and the windings. It may well be that electricity is now getting out to the metal casing. So when you touch it, you potentially could get an electric shock. An RCD would protect you by measuring the amount of electricity going out, the amount of current going out, the amount of current coming back in. And if the current coming back in is less than the current going out, it's going somewhere else, so an RCD turns off. All right with that?
Yeah.
Next one then, let's have a look. You've been asked to test an electric motor. Electric motor's characteristics for its current drain and therefore its power. I think this is the one that stumped everybody in the test, isn't it? The motor is rated at 110 volts with a current of 20 amps. What is the motor's power in watts? So how do we do that?
Current divided by voltage, isn't it?
What do you reckon, Josh?
No, P. No, current.
What's that little triangle?
It is a triangle, yeah. What do you reckon, Owen? Can you remember this one?
Or something? In the triangle, sorry.
No, I don't know.
Current times voltage, innit? P at the top, I at the bottom left, and yeah.
Or you might see it this way: P, I, V. So with the triangle, whichever answer you want, you block out the answer you want, and that gives you the other. So voltage is power over current. Current is power over voltage. Power is current times the voltage, or watts equals volts times amps. So it's not a difficult question, this one, actually. It just looks scary. So we want to know the power. So power is I times V. So P equals I times V. I is 20. V is 110. 20 times 110, 2,200 watts. Is that an option? Let's have a look. Ah, yes. There we go, look. B. Happy with that?
Yeah.
All you do is multiply current by the voltage to get the watts. Next one then. A control circuit has a capacitor connected to smooth current fluctuations. As part of the regular maintenance check, the capacitor is going to be measured. What unit would be used to measure a capacitor? I think this is one for Owen. Do you know what we measure capacitors in?
I'm guessing it's farads.
It is. Why did you guess that?
Well, you sort of put the answers up.
Well, if you look at the other three answers, they're all just fractions, aren't they? Mega, as in a million. Micro, a thousandth. A millionth, sorry. And milli, a thousandth.
Is that something to take into consideration as well, then, Ian, when it comes to specifics, like you were saying with dates on the equipment and stuff like that? If it's starting to do specifics like this, then
yeah, yes. Farads is the actual unit. Now, obviously, it might be in megafarads, it might be microfarads, it might be millifarads, but they're all fractions of a farad, aren't they? Or multiples of a farad. So it's not actually a hard question, that one. If you think about mega, micro, and milli, just being notational rather than actually being a unit, they're just standard SI units, aren't they? Mega, micro, and milli. 10 to the 6, 10 to the minus 6, 10 to the minus 3. Your standard notation. Okay, whistling on to the next one, because that was a nice easy one, wasn't it? Yes, Ian.
Yeah.
You're all still awake then?
Yeah.
As part of completing their daily task, list a maintenance operative is filling in a report on an electric motor. The report requires that the operative to represent a single phase voltage in polar form. What does that mean? A single phase voltage in polar form. Now that one's really, really unfair, because I know in the electrical appreciation that we do in year one, we won't have covered that with the mechanicals.
Honestly, I can't remember a lot of this being covered.
Single phase voltage in polar form. Is that like sine waves?
No, in polar form.
Polar form. Well, like one pole, so just 230 volts phase to neutral, isn't it?
A single phase voltage in polar form.
Polar form.
Right, so what we would do is we would represent the voltage. You see that all right?
Yeah.
And dependent on the power factor, whether the power factor is lagging or leading. For instance, if we had a power factor of 1, so that there was, we would draw it like that. If it was lagging, we would draw the power factor wherever it is, dependent on the relevant angle. Now, I know for a fact, Owen, you won't have covered this because we didn't go into this level until very much later on in the year, and it was way past basic electrical appreciation. In fact, Alex and Josh are probably looking at this and thinking, what?
Yeah.
Do you remember civil?
Capacitors, some at voltage, some at
Right. C is capacitor, L is inductor,
inductor, yeah.
V is voltage, and I, of course, is current, isn't it? So we have the voltage, our voltage line. If it's capacitive, it leads. If it's inductive, it lags by up to 90 degrees. So we would draw, that's a 90 degrees, that's inductive. Or we might draw it 90 degrees capacitive. What we do is most loads that involve electrical windings, such as motors and transformers, they would actually have an inductive element. So we use a capacitor to offset one against the other. So if you were asked to display this in polar form, you would draw the voltage and then the current, stating the relative angle. Let's have a look, see if that's one of the options, shall we? Oh, look, it's A. Does that make sense now?
Yeah, I got that one wrong when I did that.
Which one did you go for?
To use sine, because I thought when it says polar form, I just thought it was sine waves and shit like that.
As I say, this is an unfair one on the Meckies, because they just won't have covered this at all. So polar form is simply a graph form showing the relationship of current to voltage. So I don't know how to give you an easy way to remember this one, Owen, other than hope you get this exact question and the answers show value and related angle. Without spending, we probably spend 6 weeks working on this with the electricians in training centre.
Wow.
So,
and we can't remember it anyway, mate, so you got no choice about.
So to drop this question on you is a little bit unfair. So if you see anything that involves electric device where there's windings involved, then it's liable to be inductive. Lots and lots of those are inductive. So we would show the value of the current and voltage and the relationship angle between the two, the angle we call theta. I'll move on swiftly from that one because that one's not very good for the mechanicals, I'm afraid. But don't worry. Don't worry, payback is coming. There's some nasty mechanical questions for you Sparkies to have to learn as well next week.
Easy, mate. Easy.
Some nasty mechanical ones was that.
Coming for you, Owen.
Have it, mate.
A maintenance schedule then requires a power control circuit to be tested with the power off. When this test is completed, why must the capacitor be earthed?
Because it can still hold a charge in it, and when you touch it, it fucking hurts.
I've never seen it fucking hurts in an exam question option, but your description is absolutely spot on.
That's make it special there.
Yes,
yeah, a capacitor is a device that holds a charge. We use the capacitor. It's a bit like a very small rechargeable battery. It will actually hold electricity for a very short period of time. So we use it for smoothing, for instance, where there's a lot of ripple current, where the current's going up and down. The capacitor will charge when the current's high and discharge when it's low to offset it and smooth it out. So a lot of devices have got capacitors on them for smoothing. The downside is, as Alex very graphically described there, the capacitor still holds a charge. So if you go, even when the circuit's switched off, if you go sticking your fingers where you shouldn't, then pain may ensue.
Yeah.
Oh, to quote Alex,
to be fair, though, it is normally written on the door.
Yes, but one can't assume that they're going to read what it says on the door.
No, that's a bit past Meg at that one, isn't it?
Mine was at the training centre.
Well, he's learnt it the hard way, Wayne.
I just wish it was recorded.
Yeah, we'll get 250 quid for that on you being framed. He won't be rushing to do it again, though, will you, Alex?
No.
Bear in mind as well, actually, you probably had a lucky escape because some of these inverter panels operate up to 1,000 volts. So the capacitor could easily be charged far in excess of safe voltage levels.
God, I was unlucky.
You was. You'll be careful next time, though, won't you?
No.
A friend of mine who I used to work with a lot, he always used to worry about me because I spent too many years around electricity. I'm not scared of it anymore. And he always used to say I put too much faith in my gloves. You know, because I would just stick my hand in with a 10mm spanner to undo the bolts on a fuse, forgetting to discharge the capacitor and cause a dirty great big arc off my spanner. By and large, mostly the rubber gloves do protect you a little bit, but they're not there for that purpose. So,
to be fair, though, aren't most capacitors as well, don't they normally have fuses you can pull as well?
Yeah, and a lot of capacitors have a little, what we call a bleed resistor across them as well, which is a resistor that's purpose is to discharge the capacitor. It's just if you turn the power off, open the panel up quick sharp, you need to make sure that the capacitor is fully discharged. So the capacitor, we would earth the capacitor to discharge any voltage that was left in the capacitor down to zero. Next one then. What's the name of the British standard that applies to electrical installations in low voltage installations? Go on, Owen, I'll let you take this one.
Go on, Meg, I'll hand this one over to you.
Nominate. Phone a friend.
What is the name of the British standard that applies to electrical installations. Oh,
Big
go on,
blue
Kate.
book.
Oh,
Right.
8th edition.
You
No.
you electrical guys have got no excuse here, especially as you all sat in a classroom with me.
Electrical installations.
It's not called the 18th edition, mate. What's the blue book called?
BS 7671.
Or the Bible.
What's the BS stand for?
British Standard.
What's the name of the British Standard? So, here's your options. Is it the EAWR,
No.
PUA,
No.
ISO 14001, or BS 7671? Now, easy way for you to remember this one, Owen, if you get this question. The question says British Standard. All British standards are suffixed by, or prefixed by, sorry, the BS. BS stands for British Standard. It stands for something else as well, but we'll not go into that just now.
Shit.
So, British Standard. If you've got an option there where one of them says BS, that means British Standard. Interesting, though, that BS 7671 isn't a statutory document. It's a non-statutory document. So it's not the law. The EAWR is the law. But this question refers to the British Standard. Right. Last one then. What is defined as low voltage in the UK?
Is it 250 or 500?
What do you reckon, Josh?
Oh, 1000. Oh, fuck, I can't remember.
Yeah, 1,000 volts, 1,500 volts DC.
Yeah.
What we're trained to, innit? We're trained as low voltage electricians, aren't we?
What do you think, Owen?
To be honest, I'm not really sure at what point you start to say it's high voltage. Like, it's 1,000 volts AC. That sounds like a lot to me.
Right, the official definition in BS 7671 and the electricity at work regulations is low voltage in the UK is class 2 up to and including 1,000 volts AC or 1,500 volts DC. The word low is used, although, like you say, 1,000 sounds quite a high figure, doesn't it? But if you think of high voltage as being up to 400,000 volts,
Oh, well, you put it in that perspective.
yeah, then all of a sudden 1,000 seems quite low, doesn't it? When high is up to and including 400,000.
Extra low is 50, isn't it?
Extra low voltage is 50 and under, yeah.
Touch voltage.
Yeah. Except on electric vehicle charging. Touch voltage changes, doesn't it?
I'm not sure.
Come on, you did the exam.
What, for vehicle charging? I don't think I've ever done out with that.
Yeah, it's in section 7, mate. It's part of the special.
It's a special location.
Yeah.
I don't know. I've never physically touched
You
it.
don't.
Or
You won't see it. We won't see it, would we? So.
It's one of the things I mention on the course, because it's the one exception to the rule. It's raised to 70 volts, if you recall. But don't worry about that, Owen. That won't come up.
You say that now.
Now, the question is liable to be from their question bank, what is defined as low voltage in the UK? And it's up to and including 1,000 volts AC or 1,500 volts DC. So don't be thrown off by the word low, because remember what I said, 400,000 is high. Right. That's all of the questions that I've been able to extract from their question bank from the electrical point of view. Are any of those a problem to any of you?
not really, no.
What about Josh?
No, not too bad. Can you resend the stuff the logins for them tests? Because I haven't got one in my emails for some reason.
Yes, yeah. It should be. I'll send you the link again. I think initially the password is password123.
Those questions, is there any more in the bank there then, or is it just a repeat of the same 30 questions just in a different order?
It's mechanical as well.
Yeah, unfortunately, they don't want to put too many questions from the question bank in the practice test, because that would require them to sit and write more questions. So
Right, okay.
This is a relatively new standard, and at the moment they're still developing the endpoint assessment as much as anything else. Speaking of which, we've been in touch with NOCN, and the observation portion of it now, they've agreed that we can carry that out at training centre rather than on site.
Okay.
Have they said when all this is happening? Because obviously we don't even know when we're back at work yet. So.
Right. Well, under the furlough regulations, you are allowed to undergo training and assessment.
Right.
So this could take place before you go back if they don't rush and take you back. As we stand at the moment, access to training centre is restricted because if you recall, there's a big old disused mill at the back of training centre. They're knocking that down at the moment, and their work is very, very close to training centre, so they don't want anybody there just in case they go and knock the end of training centre down or anything daft like that. So there was a potential asbestos issue a few weeks back, so they want to make sure that training centre's safe before we're allowed near. It is all supposed to be completed this week, but then don't hold your breath on that one because they'll have to do environmental testing as well just to make sure that asbestos, dust and what have you. We can't risk taking anybody in training centre if there's any risk of being exposed to any dangers. From falling bits of steel to asbestos dust, it's all got to be carefully assessed by college's health and safety department first. But there's a series of tasks that you'll have to carry out. There'll be a maintenance task, there'll be a fault finding task, and I think there's probably a small installation task as well. So
is it basically a dumbed down version of AM2?
I was going to say not dissimilar to AM2 from the electrical point of view.
Yeah.
I don't know.
Have they said out about AM2 when it's starting again?
No, not at the minute. I believe the centre's still shut, but obviously comes down to how many people they want to run the course.
Yeah.
I can't understand why they can't open. There's plenty of room for social distancing. I mean, you had your own bay, for Christ's sakes.
The AM2 test it's social distanced anyway, before social distancing became a thing. The only problem is that although the bay is socially distanced, none of the other facilities are, such as the mess room facilities, the classroom facilities and all that. So, but I do know that they are frantically working to get everywhere up and running because obviously at the moment they're not making any money either. So they want to get the test centre up and running as quick as they can. But we're in the lap of the gods on that one. We will wait to be advised by them as and when that test centre's open.
Oh God.
What's AM2?
It's
shite.
Yes, this is where you actually win one, Owen.
Nice.
Because you've got one endpoint assessment to undergo. The electrical have got two. They've got to do it all again.
I feel sorry for you.
No, you don't. No, you don't.
I've got what a screwdriver is, and then I've got to go and do probably soon to go back.
Well, what we will do is we'll have another AM2 training day before you go, any of you go back. I've got to, there's certain things that you need to still have a go at that we didn't get to cover when you came in on that day before lockdown.
I never did.
Not found out whereabouts I failed them.
When he gives us some feedback,
Right.
I need to know exactly what his issues were because they seem so minor to me. You know, I'd like him to clarify exactly what the issues were and why he thought they was worthy of a fail. Because
I don't know.
Personally, doing a external resistance test is fairly straightforward, but it may well be that the trainer has a specific way he wants to see it done.
But
That's petty.
I mean, on the same hand, no, if that's the case, that should